Hello everyone, my name is Prasad Vijay Singnapure and my group members are Pratik Sanjay Hage, Tejas Rajendra Sivrame and me myself Prasad Vijay Singnapure. We are together intern at the Emertxe and we have attended an internship based on embedded system and we built a project named Car Black Box. We are from Sri Sant Gajanan College of Engineering, Shegaon, and we are pursuing third year of electronics and telecommunication. So let's see some project related topics that it first is table of contents. What is the black box? What is car black box requirements? Embedded system, microcontroller, microprocessor, difference between microcontroller and microprocessors, Pixim lab, CLCD, matrix keypad, project implementation. So we'll see what is black box first. We all have heard about the black box in the airplanes or helicopters. When the airplanes or helicopters are crashed and the agencies which are responsible to investigate the event, they definitely look for the black box first. The black box is a device used to record the things or the events that happened before the crash to investigate what was the cause of the crash. It is nothing but a device which detects the surrounding and give us the result based on what happened. So black box is implemented in car, that's why it is car black box. A black box which is used in the car is called as a car black box. The function of this black box is same as that of black box in aircrafts. Here the black box measures the acceleration, time, gears, state of the car, collision detection, etc. All these functionalities are mentioned by the car black box before the accident. So to investigate the event or accident, the law enforcement will search for the box and find the cause of the accident. The difference between the aircraft black box and the cars is that every aircraft will definitely contain a black box, but a car doesn't. It depends on the manufacturer. So some basic requirements for the project are knowledge in embedded C. You must know what is embedded C and all the data types and all the things. MPLab ID, that is integrated development environment, XC8 compiler, Pixim lab, that is a simulation tool, and PIC16F877A 16 by 8 CLCD display, tactical switch, matrix keypad, and a timer. So we'll see what is an embedded system. An embedded system is a combination of software and hardware which is used to do a particular specific task. The system can be programmable or have a fixed functionality. Industrial machines, consumer electronics, agriculture and processing industries device, automobile, medicine equipments, cameras, digital watches, household appliances, airplanes, vending machines and toys, as well as mobile devices are possible locations for an embedded system. So we'll see the detailed embedded system architecture. All these blocks are forming an embedded system block diagram. So there is a memory, sensors, analog to digital converters, digital to analog converters, actuator, manual input, and a power supply. So sensors firstly senses the output in the surrounding and then it gives to the A to D converter, which will convert the analog signal into digital converter and will give to the microprocessor. Based on the program loaded in the memory, the microprocessor will perform the instructions and it will give to the digital to analog converter. Digital to analog convert some digital process input, from coming from microprocessor and convert it into the analog signal and give it to the actuators. Actuators are the device which converts the electrical or electric signals coming from the device to an mechanical one. All these operations are done with the help of power supply and it is a main block to power the system. So there are some types of embedded system. So first standalone system, real-time system, network system, and a mobile. So firstly we'll see standalone embedded system. Standalone embedded systems are independent systems which can work on themselves. They don't depend on the host system. It takes input in digital or analog form or provided the output. Some examples of standalone embedded systems are MP3 player, micro oven, and washing machines. It can be more than this. So we'll see now real-time embedded system. A real-time embedded system is strictly time-specific, which means this embedded system provides output in a particular defined time interval. This type of embedded system provides quick response in a critical situation, which gives most priority to time-based tasks, performance, and generation of output. These real-time systems are used in ABS and all the system which required hard time. Types of real-time embedded system. There are some types of real-time hardware system, soft real-time embedded systems and hard real-time embedded systems. And other is network embedded system. Network embedded systems are connected to a network which may be wired or wireless to provide output to the attached device. They communicate with embedded web server through network. Some examples of network embedded systems: home security systems, ATM machines, card swipe machines are the examples of network embedded systems. Mobile embedded systems. It is in mobile in nature as it is mobile. So mobile embedded systems are small and easy to use and requires less resources. They are the most preferred embedded system. In portability point of view, mobile embedded systems are best. Examples of mobile embedded systems: mobile phones, digital cameras, and MP3 players are some examples of this mobile embedded systems. Contents of an embedded system. This detailed block diagram of embedded system. Which contents are used in embedded system? There are some input interfacing devices, driver circuits, then the internal structure of an processor or input output peripherals, some timer, counters, program memory, parallel port, controller, data memory, serial ports, output devices, interfacing devices, driver circuits, and application circuits and power supply. Input senses the inputs, drivers give it to the processor, and the processor with the help of the peripheral will perform the dedicated operations and give it to the output. The output device will collect it and give it to the resources. So how to choose an embedded system? Some are the parameters which define an embedded system and which we must know before choosing an embedded system. So embedded system must be low power consumptive. It must have cost efficiency, efficient use of processing power. It must be reliable, efficient use of memory is the fifth point. And now my friend will Tejas highlight some other points.
Hello everyone, I am Tejas Shivrame. So my part is what is what are microcontroller and what are microprocessors. So a controller is the hardware device or a software program that manages or directs the flow of the data between two entities. A controller is a program by the user to perform various operations. A controller can be assisted with I/O devices and can be used to perform numerous operations. But in the microprocessor is a very different object. It doesn't have any I input or output devices. It is simply a processor, and IO devices can be interfaced with it according to our application. So what is the difference between microcontroller and microprocessor? Microcontrollers are widely used in embedded systems. Microprocessors are mostly used in computer systems, as we all know that Intel and other Ryzen processors. Microcontroller has a CPU, a fixed amount of RAM and ROM, and other peripherals are embedded on it. We know that the microcontroller contains timers, counters, etc., IO devices, etc. But in microprocessor, it has only a CPU embedded into it. Okay, so let's talk about our project peripherals that are used in our project. Okay, PixSimLab architecture. This is the architecture of the PixSimLab. It contains a PIC 16F877A processor. It contains GPIO, I2C RTC EEPROM, RAM35 temperature sensor, analog to digital converter, RS-232, LEDs, buzzers, digital keypads, SSDs, matrix keypads, and CLCD, and which is character liquid crystal display. So let's talk about what is a CLCD. CLCD is character liquid crystal display. In PiximLab, there are two types of displays. One is 16:2 display and one is 16:4 display. It displays some ASCII characters as well as some special characters. It is most commonly used display. It has two types of common modes. The first is the 4-bit mode and the other is 8-bit mode. So let's talk about the tactile switch. The tactile switch is a simple push button switch which when it's pushed, the circuit is on, sorry, the conductor is on, and when we release the pressure on the push button switch, it turns off. So let's talk about MKP. The MKP means matrix keypad. This is a keypad in which number of tactile switches are connected in a row and column concept. This is used when more number of users input are required and still want to save some controller I/O lines. These keypads are most commonly used in telephones, calculators, digital lockers, etc. The MKP, which means matrix keypad, can be used to give input to the microcontroller to give specific inputs we we can input the alphabets as well. So let's see our project demo. For this project, to store the code or to write the code, we use the MPLab, and for the simulation purposes, we use the PiximLab. So the next part, which is the project demo, will be explained by my friend Pratik Hage. Thank you.
Oh, so this is our dashboard screen. It is showing currently time, event, and speed. Current event is on, and the current time is 10. The speed is now 0, 0. We can vary our speed by using pot. The speed can be varied up to 99. The highest speed can be 99, and we use these three switches to modify our events. This RB0 switch is used for collision event. As we press this, it will show the collision event, and RB1 is used for gear incrementation, whereas the RB2 switch is used for gear decrement. uh, Now, for going to the login screen, we have to press RB4. By pressing it, it will show us the login screen. uh, as I press this, it will ask for enter password. If I doesn't enter any password, it will redirect to the dashboard after some time automatically. And if I enter incomplete password, it will again redirect to the dashboard screen after some seconds. uh, as you see here, if I enter wrong password, it will only give me 3 attempts. As you see, my first attempt is exhaust. Again I enter wrong password. Now one event attempt is remaining, and as soon as I exhaust all 3 attempts, it will block me for the 60 second. As you see here, user does not able to access for the 60 second. Now I do reset. Now I enter the correct password, and you can see the login screen here. By selecting view log by using RB5, you can see the logs here. By RB4, we can navigate through view log. As I press the reset switch, so currently no events are there. Let me first create some events. uh, I can create some events by pot and gear incrementation. Now I enter the password again to view the logs.
uh, by entering correct password. Now by selecting view logs by using RB4, now you can see that the events are there. Now if you want to clear these logs, then we have to go for a menu screen and select the option clear log. uh, Now firstly I will enter the password again. As I enter the password, let me reload my Excel once again. uh, Firstly I will record some events. Now if I enter the password, right, it by RB 5, we select the clear logs, and as we see, you see the logs are clear successfully. And now if we view the logs, it will show us that no logs, because we clear all the logs. Now let's see the functionality of the change password. Let me enter the our correct password first. uh, by using navigation key, means RB4, we can go to the change password, and it will ask to enter the new password. Let me add our new password first, and it will ask again to re-enter the new password. You can add the same password you entered previously, and it shows now password has been changed successfully. This is all about this project. Thank you.